so I like this one because it's seemingly, well, here, let me just go through it. Okay, so here we go. So on worksheet 8.1, number 14, it says at t equals 0, we've got a ball that's got a mass of 1 kilograms, and at t equals 0, it is thrown from a 200-meter tall tower. So our height is going to be 200 meters. And it's got a velocity of 18I plus 24J meters per second. Is everybody cool with this notation? Yep. This is just the x and y velocities, yes? Yep. Cool. All right. It says, what's the change in U, so the change in potential energy of the ball Earth system between t equals 0 and t equals 6 seconds? I'm just trying to figure out what the most efficient way of doing this is going to be.
Maybe finding final velocity and then just...
I don't even think you need... Oh, yeah, yes, you do need to do that. I'm sorry. Okay, so the idea is this. So let's make just kind of a quick sketch so we can kind of process what's going on. So the fact that these are both positive means that our object is being fired this way, right? So that it's got an x velocity of 18 and a y velocity of 24, right? And so it's going to go off of the building like this, right? Cool? And so what we want to know is what the change in gravitational potential energy is at the end of those 6 seconds, yes? All right, so before we get to the math, tell me some stuff we know conceptually. Like, what are the concepts that are going to help us solve this thing? Sure, Z, you want to get started?
Yeah, the only force is conservative.
Good, the only force on it is conservative, gravity. So somebody else, why is that helpful? Sure, what do we got, Patrick? Total energy is going to be constant, right? So if I've lost or gained potential energy, then I've either gained or lost kinetic, right? Follow? So there's a couple ways we could go about this. Option one is we could use some kinematics equations and find out how much the ball moves down during those 6 seconds. Or up, I guess, during those 6 seconds. Right? I don't know. There's a bunch of ways you could solve this. I guess my knee-jerk reaction is this is going to be a velocity. So I think I'm going to just focus on the vertical motion. And let's find the change in vertical position. Does that make sense? Okay. So vertically, here's what we've got. Oops. So vertically, here's what I know. I know that my vertical velocity initially is 24 meters a second. I know that 6 seconds are going to go by. I know that my acceleration vertically is negative 9.8 meters a second squared. Do you guys agree that I could find my change in vertical position using that information? Okay. So that would be, what, 1/2 AY times T squared plus VOY times T, right? Yep. Does that make sense? Everybody okay with my notation in this equation? Cam, you good? Yeah. This is, by no means is this the only way to do it, but this will work. So I'm going to have, let's see, negative 4.9 times 6 squared plus 24 times 6. So I get negative 32.4 meters. So let's figure out how much gravitational potential energy we lose. We're going to go down 32.4 meters. So delta U should be mg delta y, right? So our mass was a kilogram. G is 9.8 meters a second squared. Delta y is negative 32.4 meters. So whatever that gives you. negative 317.5 joules. So not super enlightening. I think that's probably the quickest way to do it. Does it make sense, you guys?
Yeah.
All right, I think the other way to do it, and I think this is what Zach started to say. I think it was Zach that said this. The other way you could do it is you could find the velocity after 6 seconds. So that'll work. So if I wanted to plug this into the kinetic energy equation, what would I have to do? How do I deal with the fact that I've got 18I and 24J? Yeah, you'd have to find the hypotenuse, find the magnitude of the hypotenuse. Okay, Daniel, please. Yeah.
Would you have to account for the fact that you're throwing it up, so like we have to take it from 0?
It doesn't matter because when you calculate kinetic energy is a scalar. In other words, it doesn't have direction. So this, the v in this equation is the magnitude of the velocity. Okay, so direction plays no bearing in it.
No, but I thought you said that you were going to use that velocity to find the velocity at 6 seconds.
Oh, I see what you're saying. I see what you're saying, yes. So, I gotcha. So, to find the velocity at 6 seconds, what you'd do is you'd say, all right, well, my horizontal velocity is going to stay constant, right? So, it's going to be 18I plus, how do I find the vertical velocity after 6 seconds, you guys?
Use the 0 on acceleration and time.
What's your starting vertical velocity? What's wrong? Okay, well, I mean, do you understand that this is your vertical velocity at time equals 0?
Yeah.
So this is what your vertical velocity begins at, and then what does your vertical velocity do every second?
Decrease, but I thought it was going like that.
It is.
So isn't it the velocity going to be 0 at the top?
But we don't know that it's at the top after 6 seconds.
Right, but wouldn't it have to decrease and then increase again? So wouldn't it be like not constantly decreasing?
So vertically, here's what we've got. Bear with me here for a second. I know what you're asking. So our initial vertical velocity is 24, right? Good. I think some of this is because you didn't do honors last year, so I think you and I might just need to talk later. Vertically, that's our acceleration. Our time is 6 seconds, right? So for simplicity, let's just use 10. So the velocity is going to go 24, 14, 4, right? Eventually it'll hit 0, but then it becomes negative. So you don't need to break it up into 2 parts, because if I use this equation, then I get the 24 plus how much it decreases. And so it gives you negative whatever this is.
Okay.
Do you know what I mean? Like it's going to go down below 0.
I thought I tried that, but I didn't get it right. That's
Gotcha. All right, so anyway, so that gives you your vertical velocity. So what, I don't know what that is, 24 minus 58.8, so 34.8, negative 34.8.
Yep.
So then you find the hypotenuse and plug that into your kinetic energy equation and figure out how much kinetic energy you gained. That has to be how much potential energy you lost. Cool? All right. Questiones on whatever number that was. Cam, are you good?
Yeah.
Everybody happy?